Hello everyone, in this session let us discuss about pin diagram and memory organization of 8051 microcontrollers. Yeah, this is a pin diagram of 8051 microcontroller, which is a 40 pin chip, and then out of it the 32 pins are divided into 4 ports and the rest of the pins having this individual functionality. Let us discuss in detail. Yeah, first set of pins, that is pin number 1 to 8, are given for port 1 operation. Basically port 1 is only work for input output module operations only. It doesn't have any other special functions. And pin number 9 is a reset pin, which will use to reset entire the functionality of 8051 microcontroller. And next, pin number 10 to 17, the 8 pins are dedicated for port 3, one of the other odd port. It is used for both bidirectional input output operations, as well as port 3 also having each and every pin of port 3 having its special function, its own special function. Like you can see clearly here, receive data, transmit data, and interrupt 0, interrupt 1, timer 0, timer 1, and read write operations. Means each and every pin of port 3 having all special functions along with the general purpose input output operations. And pin number 18 and 19, they both used for external oscillator interfacing. As we know that 8051 microcontroller needs a clock signal which is generated by an external oscillator that will be connected with these two pin numbers. Next, 20th pin will provide ground to the 8051 microcontroller. Next, from pin number 21 to 28, these 8 pins are dedicated for port 2, one of the even port, which will work for general purpose input output operation. Along with that, it also used for higher order address bus. As we know that 8051 microcontroller having 16-bit address bus, in which 8-bit is multiplexed with other port, and the other higher order 8-bit address bus is worked with the port 2. Next, pin number 29, it is program store enable. This active low in this pin will access the external memory, external program memory. It can access the address locations and data from the external memory connected to 8051 microcontroller. Next, pin number 30, it is ALE, or active low of program. It is ALE, basically we will use for demultiplexing of multiplexed address and data bus. If you see here, you can observe carefully, these 8 bits of port 0 or multiplexed address and data bus, but same 8-bit bus is working for address as well as data. So the current status, if you think about the current status of the bus, whether it is carrying the address of the memory location, or whether it is carrying the data for various operands, how to identify this, that will be decided by ALE, that address latch enable. Simply address latch enable is logic 1 or logic 0. Based on that, the bus will be divided as address bus or data bus. Next, EA basically is active low signal, which is called as external access. This is like a permission to access external memory by the 8051 microcontroller. Next, the remaining pin number 32 to 39 is dedicated for port 0, that is the first even port, and this is the port 0 will work for both general purpose operations as well as multiplexed address and data operations. And last pin is 40 pin, it is VCC or basic power supply, that is 5 volts DC supply required for 8051 microcontroller. Okay, this is complete or detailed information about the 8051 microcontroller pin diagram, all the 40 pins and their respective functionality we have seen. And now, as we discussed in the port 3, each and every pin of port 3 having its own functionality. Let's discuss in detail about each and every pin of it. Yes, you can see the all 8 pins of port 3 having their alternate function. If you see port 3 pin number 0, it is worked for receiving of serial data or transmitting of serial data. Likewise, means 2 pins, they are working for serial communication operations. They can receive data serially, they can send data serially to the input output ports. Next, pin number port 3.2 and port 3.3. These two pins are dedicatedly work for interrupt service routines or the various other devices which will generate interrupt through these two pin numbers. These two are active low input signals where INT0 is external interrupt 0 and INT1 is the external interrupt 1. Both are external interrupt signals. And other two pins like port 3 pin number 4 and port 3 pin number 5, they work for timer 0 and timer 1. As earlier we discussed, two 16-bit timer counter operations or timers we have within the 8051 microcontroller, and then for external operations it acts as a timer. So for timer 0, one port and pin number 3.4 and another pin number 3.5 is timer 1. Next, the last two pins, that is port 3 pin number 6 and port 3 pin number 7, they work for basically read-write operations, read-write operation of external memory. There is a writing operation and reading operation, and here both pins are active low type signals. Okay, this is clear description about each and every special function of the port 3 pins. Now let us go with the memory organization and how the internal memory of 8051 microcontroller will be organized. Let us discuss in detail first the RAM organization. As we know that 8051 microcontroller consists of 128 bytes of RAM, which in turn divide into 3 parts, and each part having its own special features and functionalities. Let us see that complete 128 bytes is divided into 3 parts. The first part is of size 32 bytes, and second part is of 16 bytes, and the remaining 80 bytes are for general purpose operations. If you see that first part of RAM, that is working registers, the 32 bytes of memory of RAM is given for working registers. Those are also called as bank of registers. Here you can see clear in the figure there are 4 bank of registers, each of 8 registers, and each register size is 8 bits. If you see here, each bank of size 8 registers, and again each register of size 8 bit, okay. So likewise total 32 bytes of memory is divided into 4 bank of registers and named as bank 0, bank 1, bank 2 and bank 3, and these are all the 32 registers. If you see each and every bank having 8 registers, those 8 registers named as R0, R1, R2, R3, R4, R5 and R6 and R7. The same names are repeated for all the rest of 4 bank of registers. Okay, so these registers are generally used for all the set of general purpose operation to store the temporary data, that is temporary input output data and results. Okay, and one of the bank of registers, that is bank 1, also used for this basic stack operations. There is stack memory. We will use this one of the bank of registers, that is 8 registers we will use for stack operation, that is push and pop operation will carry out to store the address location of current running program when an interrupt service routine occurs. Next, these are okay. Next we'll discuss about the second partition, that is 16 bytes of memory, that is address location 20 to 2F. Those are 16 bytes, or these all are bit addressable memory locations. As we know that 8051 microcontroller can perform both byte addressable operations and as well as bit addressable operations, and this set of operations called bit addressable, where you can work on individual bit modification also. Okay, next the rest of 80 bytes of memory, that is 30 to 7F, are given for general purpose operations. In this 80 bytes only, there are few bytes of memory they allocated for even special function registers also. Okay, this is the clear or in detailed organization of internal RAM of 8051 microcontroller. Now let us see that overall memory organization of 8051 microcontroller. Yes, this is a memory organization of 8051 microcontroller. If you think about this, the basic features we already discussed. Yes, an 8051 chip. This is completely 8051 chip, consists of internal RAM along with SFRs, that is 128 bytes, and there is a 4 KB of EPROM or ROM memory. 4 KB of ROM memory. This is built in into a single chip of microcontroller. Along with that, we know that as it is having 16 address lines, 16 address lines. So the 16 address line, with the help of 16 address line, it is capable of accessing how much amount of memory? That is 2 power 16, that is 64 KB of memory. 2 power 16, that equal to 64 KB of memory it can access externally, right? So that 64 KB of memory may be either data memory or program memory, depends upon type of application or requirement. We can interconnect an external 64 KB of memory chips, one for random access memory operation, that is data operation, and another is for code or ROM. Okay, so likewise the complete memory organization of 8051 microcontroller includes the internal RAM and ROM of size 128 bytes and 4 kilobytes respectively, as well as it can also access a maximum of 64 kilobytes of external data memory as RAM and program memory or code memory as ROM. Okay, likewise we can have two different types of memories, that is RAM and ROM, as well as two different kinds of accessing, that is internal access and external access of memory can be available in 8051 microcontroller. Okay, this is about a clear description about the pin diagram, all the 40 pins discussed, and along with this, what are the different types of memories we have in the 8051 microcontroller, how they are going to arrange and access by the controller for various set of operations we learned in this session. Thank you.